All right, let's talk about the device you're probably using to watch this right now, the computer. We use them every single day, but we don't always stop to think about the incredible magic that's happening inside. So, let's pull back the curtain and decode it.
I mean, seriously, you've probably spent thousands of hours looking at a screen like this. But what is actually going on behind that glass? Well, stick around because by the end of this, you're not only going to get the fundamentals, you'll even know how to walk into a store and confidently buy the right one for you. So, what even is a computer when you strip it all down? It's actually super simple. It's just a machine that does three things. It accepts information, which we call data, it processes that data based on a set of instructions, and then it gives you back a result. That's it. Input, process, output. That's the secret sauce to everything a computer does.
Now, every single computer out there, from your watch to a supercomputer, is made of two main things. First up, you have the hardware. That's all the physical stuff you can actually pick up and touch. The screen, the keyboard, the chips. Then you have the software. That's the invisible stuff, the programs and code that tell the hardware what to do. The best way to think about it is like this. Hardware is the body, but the software? That's the brain and the soul that brings it to life.
And that simple idea of hardware plus software, well, it applies to a massive family of different devices. So let's take a quick look at the computer family tree, because there's pretty much a computer designed for every single job imaginable.
You can basically split this whole family tree right down the middle. On one side, you've got all the personal and mobile computers that we use every day. You know, the stuff in our pockets, on our wrists, and in our backpacks. But on the other side, you have the heavy hitters, the massive enterprise and infrastructure computers that run our banks, power big companies, and help scientists make incredible discoveries.
And if we just zoom in on our side of the family, the personal computers, you can see how each one has its own special talent, right? A wearable's all about being super portable for quick info and health tracking. Your smartphone is your pocket-sized hub for communication and apps. A laptop gives you the power to be productive anywhere. And the good old desktop, that's where you go for maximum power and the freedom to upgrade it whenever you want.
Okay, now for the really fun part. Let's get our hands dirty, metaphorically of course, and crack open that magic box to see what's actually making everything tick inside. We're talking about the hardware.
So first things first, how do we get our thoughts and commands into the computer? We use input devices. You can think of these as the computer's senses. Its ears, its eyes, its sense of touch. They're literally how we talk to the machine. Just look at all the different ways we give commands. Your keyboard turns your typing into text. Your mouse turns your hand movements into a cursor on the screen. A microphone turns your voice into a digital signal. They all do the same basic job, translating our real-world actions into a language the computer can understand.
But hey, communication is a two-way street, right? Once the computer has done its job, it needs a way to talk back to us. And that's where output devices come into play. They take all that digital information and present it in a way our human senses can actually perceive.
And these are the ones we're most familiar with. Your monitor takes data and turns it into images we can see. Speakers turn data into sounds we can hear. A printer even turns data into a physical object we can hold. It's all about translation.
Okay, this is where it gets really cool. Some devices aren't just one-way streets. They can do both jobs. We call these input/output devices, or I/O for short. They're the true conversationalists of the hardware world.
A touchscreen is the perfect example. You give it input by touching it, and it gives you output by showing you something on the screen. A headset with a mic lets you listen, that's output, and speak, that's input. Even a hard drive is an I/O device. It receives data when you save a file and sends data when you open one. It's a constant back and forth. So, all these different devices, your keyboard, your monitor, everything, they all have to connect to the main event, and that's the system unit. This is the box, the case, that holds the absolute most critical components. This is the command center, where the real thinking happens.
And inside that system unit, you've got this crucial partnership between two components. First is the CPU, the central processing unit. That's the brain. It does all the calculations and executes all the instructions. Then you have RAM, or random access memory. Now, if the CPU is the brain, think of RAM as its desk. It's the temporary workspace where the brain keeps everything it's working on right now. The bigger your desk, the more things you can work on at once without getting cluttered and slowing down. It's that simple.
Okay, so we've covered the body, all that physical hardware. But now it's time to talk about the ghost in the machine, the software that actually brings all that silicon and plastic to life.
At its core, software is really just a list of instructions. It's like a director on a movie set, telling all the hardware actors exactly what to do, how to do it, and when. Without software, your computer is just a very, very expensive and complicated paperweight.
And software basically comes in two main flavors. You've got the operating system, or OS. Think of this as the general manager of the entire computer. It's in charge of everything. And then you have application programs, which we all just call apps. These are the specialized tools you use to get specific jobs done, like writing a document, browsing the internet, or playing a game.
The operating system is the world you live in when you use your computer. It creates that visual environment, the desktop, the icons, the windows, that lets you, a human, easily tell the complex machine what you want it to do. It's the ultimate translator between you and the hardware.
Okay, we've looked at the hardware, we've looked at the software, we know how it all works together. Now let's put that knowledge to work and figure out the most important part, how to choose the perfect computer for you.
Because it can feel pretty overwhelming, can it? You go online and you're hit with CPUs, RAM, gigabytes, different operating systems, laptops, desktops. How in the world do you cut through all that noise and just pick the right one? Well, it's actually much simpler than it looks.
The whole process really just boils down to 4 simple steps. First, and this is the most important, figure out what you actually need it for. Is it for work, school, gaming, or just browsing the web? Second, set a budget. Third, once you know your needs, you can compare the big 3 specs, the CPU, the RAM, and the storage. And finally, just pick the operating system you like using the most. And this chart right here is basically your cheat sheet. Let's break it down. For storage, you almost always want an SSD. It's a newer, much faster type of drive that makes your computer boot up and open programs in a snap. Now, if you're just doing general stuff like email and web browsing, a mid-range brain, or CPU, and 8 gigabytes of disk space, or RAM, is perfect. If you're a professional who needs to multitask a lot, bump that up to a stronger CPU and 16 gigs of RAM. And if you're a serious gamer or a content creator, you'll want a high-end CPU, at least 16 gigs of RAM, and a powerful dedicated graphics card, or GPU, to handle all those intense visuals.
So there you have it. The computer is no longer a mysterious black box. It's just a collection of understandable parts all working together. Hardware and software, input and output. It's not just a machine, it's one of the most powerful tools for creativity and discovery ever invented. So the only real question left is, now that you know how it works, what are you going to do with yours?